In this video, we're going to talk about modeling fraud and specifically this article in Journal of Accounting Research from uh, published 2019. It's one of the more recent attempts at modeling fraud. And so what they use is a machine learning approach called Ensemble method or Ensemble learning, or it has different terms. What it is combining a bunch of different models. Before we start, there is a correction for this article. You can go to this erratum. They had posted their code, which is a great thing to do, but someone found some errors and it changed a couple of the tables. Not the one we're going to look at, but a couple of things. All right. So they try and come up with a model to predict fraud. We're going to talk about table 4. And in table 4, they compare uh, one, two, three, 4 different uh, inputs to models, or 4 different models. So the first model, they use 28 financial statement items, so like revenue and assets, things like that. They have another one that's just financial ratios, and prior research had predicted fraud using some of these financial ratios. The next one, they use the financial ratios and the raw items. And then the last one, they use a large set, 294 raw financial items. And so what they're trying to do is say, with these methods, with this model, they're going to compare the model that has these variables, the model that has these variables, these ones, and these ones. Let me walk through a couple of measures they used. There are lots of different ways you can measure performance. The ones that they're introducing that I think are pretty intuitive to think about are the sensitivity and precision. Of course, there are other ones like their AUC. This is a standard statistics version. But let's talk about these because I think they're easy to understand and think about. So sensitivity is this is a definition they come up with, and it says they run their model, then in training data, then they apply it in testing data. And what they do is they say, let's look at the top 1%. So what comes out is a prediction of the probability that that company year has a fraud. And so they're going to sort the observations, and they say this 1%, the highest 1%, are the most likely to commit fraud. So in terms of their model, the top 1% are the ones they're most confident will be ones that commit fraud. If they get a large proportion of those that commit fraud, that's successful. So the sensitivity is in that from that 1%, how many do they get right versus missing other ones? So if they caught every single fraud instance in that top 1%, then this would be 100%. If they capture, the more they capture in that top 1%, the higher this number is. The more they miss ones, so let's say it's in the 90s, instead of in the top 1%, it's in the next percent. So like the top 2%. If it misses that, then this is going to be a lower number. So it isn't exactly precise in terms of there is a fraud and we predicted there's a fraud. It is a measure of like the ones that we think are most likely to commit fraud are the ones that, the highest prediction are the ones that are capturing it. Okay, so here they find that 5% of those 5% of the fraud instances are in that top 1% that they predict. Okay, so that means there's 95% of the fraud cases don't end up in that top part. Now, we could just, what would have been nice is to show, well, how far down do you have to go in the predictions before you get most of the fraud instances. Um, that's, I would like to know that. But if we're taking the sort of pejorative view, they're missing a lot of fraud outcomes. Five, correctly getting 5% isn't all that impressive, but it's uh, you know from all these models that have tried to do this before, it's really hard to predict fraud, and part of that reason is that um, fraud instances aren't that common, so we don't really have a whole lot to work with. And if it were easy to commit to capture fraud, people just would never commit fraud because then everyone would know. Okay, but that I think is not all that comforting in terms of making a decision based on it. Uh, but it's better than, as we'll talk about, it's better than what other models have been able to do. The precision, what this does is captures the percent of those that are in that top 1% that are frauds. So this sensitivity captures how many of the fraud cases end up in that top 1%. This one says of the top 1%, how many of those are fraud? So about 4.5% of those. That means in that top 1%, 95% of those don't have fraud. Again, comes with lots of caveats that it's hard to detect fraud, and maybe they had it and we didn't detect it, or other reasons. But I think this gives a nice insight into the difficulty with some prediction models. Neither of these should give you a whole lot of confidence that when you predict there is fraud, you determine, you're pretty confident that there is fraud, but it's better than they have. Okay, so we got 28. This seems to work okay. Well, all of these other variations do worse. So the 14 financial ratios that have been used in prior research doesn't do as well. If you combine the 14 ratios and the 28 from theirs, it does worse. Well, why might that be? And this is even more the case with using all 294 of the variables they have. This is probably happening because of overfitting. So this is trained on a training data set, and then the tests are based on a separate data set. So this is why this is called out of sample. That means they go to a new data set, which is called a testing data set, and they see how it works. Well, the more variables you have in the model, the better it should capture what's going on in data. So in the training data, it should do even better. When you move on to testing data, if the training data, the model overfit things that are unique to that training data, then moving to out of sample may not perform as well. That's called overfitting. So probably the reason this doesn't do as well is because more data in the model overfits the training data. All right. So the main points here, it's hard to predict fraud. Perhaps having a prediction of fraud is better than having nothing, and it might heighten how careful you are about examining a company if you're a regulator or an investor, but probably not all that confident that your predictions are actually going to happen. And maybe if you are going to try and use a model to predict fraud, thinking about the approach they use here might be better than some other approaches used previously.